Welcome to How the Heavens Go. I'm your host, Mark Lesmeister. In our prior episodes, we looked at how people tried to explain the motions of the sun and the planets, but we have mostly ignored the second brightest object in the sky, namely the moon. So this episode is devoted to the moon. I've named this episode Artemis, after the goddess of the moon in the hunt from Greek mythology. Artemis is also the name of the current series of NASA moon missions. The most basic motion of the moon is the one that it shares with the sun, the planets, and the stars. This is the daily or diurnal motion of the moon across the sky from east to west. Unlike the planets and the stars, because the moon is so bright, it is often visible during the day. And unlike the stars, the moon appears to change shape following a regular cycle called a lunation. That cycle goes, starting with the new moon, when the moon isn't visible to the naked eye, to waxing crescent, to first quarter, to waxing gibbous, to full moon, to waning gibbous, to last quarter, to waning crescent, and then back to new moon. These are the names for the lunar phases that astronomers use today. But the moon has been observed for millennia. In fact, it's difficult to imagine a culture that would not have observed the moon. So, as we might expect, different cultures have different names for these phases. Consider the Lakota, one of the Native American peoples that are prevalent in South Dakota, where I grew up. The Lakota lunar cycle begins with a full moon, the name of which translates to round moon. The last quarter moon is called a bitten-off moon. A new moon is a dead moon, and the first quarter moon is called a half moon. A lunar cycle or lunation lasts about a month. In fact, the word month is related to the word moon. In the traditional Islamic calendar, the new month begins when the crescent moon first appears. The phases of the moon are caused by changes in the parts of the moon that are illuminated by the sun as seen from the earth. We can explain this using the model. Here we see the moon and sun lined up in the same direction from planet Earth. Let's see what this looks like when the light is coming from the direction of the sun. I placed a small flashlight on the right side of the model to simulate that light. The side of the moon that is illuminated by the sun is not visible from the Earth. So this is the new moon. We should be more specific about what we mean by lined up. In this model, the centers of the sun, Earth, and moon are all in the plane of the Earth's orbit, a plane known as the ecliptic plane. So lined up means that the sun and the moon are both in the same direction from the Earth in the plane of the ecliptic. In reality, though, the orbit of the moon is tilted relative to the ecliptic plane. So the moon can be on the same side of the Earth as the sun, but appear to be above or below the sun. The model shows the sun as being much larger than the moon. Indeed, the sun is about 400 times wider than the moon. However, it is also about 400 times farther away from the Earth than the moon is. So the angular size of the sun and moon, how big they appear to be in the sky, are about the same. That means the moon is usually above or below the sun at new moon. It is only in front of the sun during a solar eclipse. We'll talk about that later. Let's move the model from new moon through waxing crescent to first quarter. If you look at the base of the stick supporting the moon, you can see a depiction of the moon phase the model is currently displaying. In this configuration, one half of the side of the moon facing us is illuminated, so this is sometimes called a half moon. The name first quarter comes from the fact that this is the moon phase at the completion of one quarter of the cycle. When the moon is on the opposite side of the Earth from the sun, we get a full moon. Just as with a new moon, the moon may be above or below the plane of the ecliptic. I had to raise the light slightly so the moon would be illuminated. Here's the situation at last quarter. If you think about what this looks like from the Earth, the opposite side of the moon is illuminated now. The duration of a lunar cycle averages about 29.5 days. This is called a synodic month, from a Greek word meaning meeting, referring in this case to the meeting of the sun and the moon at each new moon. It only takes 27 days for the moon to go around the Earth relative to the fixed stars. This is called a sidereal month. The synodic month is longer because the Earth has shifted in its orbit of the sun, so the moon has to move just a little bit more to be in the same position relative to the sun. The synodic month of 29 and a half days doesn't fit neatly into the solar year of 365 and a quarter days. In some solar years, there may be 12 new moons, and others 13. Some cultures which use calendars based on the moon cycle just accept that fact. The Islamic lunar calendar has 12 synodic months in a year of 354 or 355 days. This calendar is used mostly for religious purposes. Other cultures link their lunar calendar to specific points in the solar cycle, such as the equinox, or to events dependent on the solar cycle. In this version of the Lakota calendar, the year begins with a full moon nearest the time when the ducks migrate back north in the spring. There are usually 12 full moons per year, but approximately every third year there will be 13 full moons. The 13th full moon of the year is called disappeared. A lunar eclipse happens when the moon falls in the shadow of the Earth. In our model, this happens during every full moon when the moon is lined up behind the Earth relative to the sun. But since the moon may be above or below the plane of the ecliptic during a full moon, on average we experience a lunar eclipse about twice per year. A solar eclipse occurs when part of the Earth falls in the shadow of the moon. Again, this would happen every new moon if the moon's orbit was in the plane of the ecliptic, but since the moon's orbit is tilted, it happens about twice per year on average. Fortunately for us, the sun and moon have approximately the same angular size when viewed from Earth, and that means that about once every 18 months, somewhere in the world, the moon will completely block the sun, leaving the corona of the sun visible. The moon in our model has a smooth, featureless appearance, but we know that is not the case for the real moon. The beauty of the moon has influenced poets and philosophers for centuries. Galileo used his observations of the moon to argue that celestial objects were marked with imperfections just as objects on the Earth were. Another important feature revealed by the model is the way the moon always presents the same face to the Earth. If I put an arrow on the model moon that points toward the Earth, we can see that the arrow continues to point toward the Earth over the entire orbit. This happens with the real moon as well. As the moon revolves around the Earth, it rotates on its axis at the same rate once per orbit of the Earth. This wasn't always the case. A long time ago, the moon rotated on its axis much faster than it revolved around the Earth. But over time, the pull of gravity gradually caused the moon's rotation rate to synchronize with the orbital rate. This process is called tidal locking. Because the moon is tidally locked, we did not know what the other side of the moon looked like until quite recently. This led to the term dark side of the moon, with dark meaning unknown. Astronomers prefer the phrase far side of the moon because of the misunderstandings the phrase dark side of the moon produces. First with uncrewed probes in the 1960s, and then beginning with Apollo 8 in 1968 with crewed missions, scientists started to learn more about what the far side of the moon looked like. We now know that the far side has more craters than the near side. If you would like to learn more about the Apollo missions and what they revealed about the moon's composition and history, check out my Spirit of Apollo series. We are still learning new things about the moon all the time. The upcoming Artemis 2 mission will send human beings to the vicinity of the moon for the first time since 1972. Because they will be in a higher orbit around the moon than that used for the Apollo missions, they will travel farther away from the Earth than any humans in history. They will be the first humans to see some parts of the moon directly. As I make this video, NASA is addressing some of the problems that were identified in a wet dress rehearsal of the upcoming launch. If those problems can be fixed, Artemis 2 may launch at the next launch opportunity, which comes in about a month from now in early March. So to the crew of Artemis 2, I wish you Godspeed, and to my viewers, look to the stars.